Hello everyone, welcome to 360 on History, your one-stop resource for blogs, podcasts and videos on science, history and nature. Please check out the website 360onhistory.com, join us on social media and subscribe to 360 on History podcast on YouTube. You can also subscribe to the audio version wherever you get your podcasts. Exciting topic today, people. We have sent out 2 missions to asteroids that will bring back soil samples. Now, that's no small feat. The asteroids are moving at a speed of 25 kilometers per second. Their speed varies based on their distance from the Sun. Meanwhile, these 2 spacecraft are entering the orbit of the asteroids, identifying sample sites, collecting soil samples, leaving the orbit, sending back data to Earth, and of course, coming back to Earth with those soil samples. It's very cool. Although we have witnessed some fantastic advances in space exploration recently and learned about Jupiter, Saturn, Pluto, and even more about exoplanets, which are basically planets that orbit other stars, one thing we have rarely been able to do is actually analyze the composition of solar system bodies in our labs on Earth. This might soon be accomplished thanks to these 2 missions, Hayabusa2 and OSIRIS REx, both of which have the lofty goals of bringing back samples from these 2 asteroids. Now, before we talk about the missions, let's go over what asteroids really are and where they come from. They are rocky, airless bodies left over from the early days of the formation of our solar system 4.5 billion years ago. Basically, they're space rubble. The current asteroid count, according to NASA, is 958,729. That means these are the only ones that have been counted. There are probably millions out there. Most of this lumpy, potato-shaped rubble is orbiting the Sun between Mars and Jupiter, known as the main asteroid belt. They range from the largest one, Vesta, which is 530 kilometers in diameter, to those less than 10 meters. Here's a fun fact. The total mass of all the asteroids combined is less than that of our moon. So that scene from Star Wars where the Millennium Falcon had to pass through an asteroid belt and kept getting hit by them incessantly is probably inaccurate, because if we consider our asteroid belt, there's miles and miles of space between each asteroid. Han Solo can easily drive his spacecraft through it. There is another body in the asteroid belt called Ceres, which is actually a dwarf planet. Scientists believe that the asteroid belt had enough material for another planet to have formed billions of years ago, and maybe Ceres could have been that planet. But 4.5 billion years ago, Jupiter traveled to the innermost solar system and scattered all the material in its path because of its gravitational field. So it is because of Jupiter that we have an asteroid belt instead of another planet. And it is also because of Jupiter that Ceres is not able to clear its neighborhood from asteroids that are in its orbit, which is one of the preconditions for a body to be classified as a planet. It is supposed to have cleared out a path of its orbit. So this godfather of all planets, Jupiter, once in a while chucks an asteroid our way. But mostly its gravity protects Earth from oncoming asteroids and comets that might hit us. NASA's Dawn spacecraft, launched in 2007, visited the largest asteroid Vesta in 2011 and then went on to Ceres in 2015. This was essentially the first time a spacecraft had orbited a body in the asteroid belt. A side note about Ceres, by the way, it is named after the goddess of grains and nutritious food crops. And if you're one of those people who got upset when Pluto was demoted to a dwarf planet, then you can blame Ceres, because it was only after studying Ceres that scientists understood its similarities to Pluto, and this led to Pluto being designated a dwarf planet. There are also asteroids called Jupiter Trojans, which are a group that share Jupiter's orbit around the Sun. And their estimated number is over 7,000, although scientists think there could be many, many more. So let's come to the exciting bit now. First up is Hayabusa2, a Japan Aerospace Exploration Agency or JAXA's mission with the objective to rendezvous with an asteroid called Ryugu, land a probe and rovers on its surface, and then return to Earth with soil samples. Launched in 2014, Hayabusa arrived at Ryugu in June 2018. 2 rovers and a lander were deployed on Ryugu's surface in September and October 2018. Hayabusa2 follows on from the earlier Hayabusa mission, which also returned soil samples in 2010, and those samples were analyzed. But with new technology, the analysis of the new samples will reveal so much more. An exciting thing happened in February 2019 when Hayabusa2 fired an impactor into Ryugu, created an artificial crater, and collected subsurface soil samples that are now on their way back to Earth, along with 2 other soil samples. Hayabusa2 left Ryugu in November 2019 and will be returning to Earth later in 2020, this year. The science instruments on the orbiter and rovers investigated the surface of the asteroid, providing environmental and geological data about the samples collected, which will be analyzed at JAXA's Extraterrestrial Sample Curation Center, which in itself is a cool name. When Hayabusa2 flies past Earth in late 2020, it will release the capsule containing the soil samples, which will re-enter the Earth's atmosphere, deploy a radar reflective parachute at an altitude of about 10 kilometers, and eject its heat shields while transmitting a position beacon signal. The plan is to land the sample capsule at the Woomera test range in Australia. What will happen to Hayabusa2? It will retain 30 kilograms of its propellant with the hope that this will be able to extend its mission and fly to new targets. Our second mission is NASA's OsirisRex. Its objective is to travel to asteroid Bennu and bring back a 60-gram sample. Launched in September 2016, OsirisRex rendezvoused with Bennu in December 2018. On board, it has telecommunication equipment, but more importantly, it carries instruments to study the asteroid in many wavelengths, take images, and of course, retrieve the sample. Science communication fun fact. The Planetary Society organized a campaign for people to have their names or artwork saved on a microchip, which the spacecraft now carries. Also, the asteroid Bennu was named by 9-year-old Michael Puzio, who won a contest to name it. When OsirisRex entered Bennu's orbit in December 2018 at approximately 1.75 kilometers, it started remote sensing and mapping exercises to select the sample site. At this altitude, it takes the spacecraft 62 hours to orbit Bennu. At the end of a detailed survey, it entered a closer orbit with a radius of 1 kilometer. In December 2019, after analyzing the surface of the asteroid for a target sample area, the team leading the mission selected a collection site out of 4 possible candidates, and they called this site Nightingale. It is located in a crater in the northern hemisphere, and NASA keeps releasing cool images of it. OsirisRex is expected to return in September 2023, and just like Hayabusa2, a capsule will be landed under a parachute at the US Air Force's Utah Test and Training Range. The samples will be analyzed at NASA's Astromaterials Research and Exploration Science Directorate and at Japan's Extraterrestrial Sample Curation Center, the one we talked about earlier. Now, you might ask what the point of all this is. Well, cool science missions aside, bringing back soil samples from asteroids is important because they're basically remnants from the birth of our solar system. They may have carbonaceous material, and carbon is a necessary element for life. They may also have amino acids, which have already been found in meteorites and comet samples, and which are organic molecules also necessary for life. All of this will help us understand how our solar system formed and perhaps increase our understanding of the beginnings of life on Earth. If that isn't a cool objective, I don't know what is. We hope you enjoyed today's show. Please do subscribe to the YouTube channel and join us on social media. You can find all the information in the description box. Bye.